All right. Hi, everybody. I'm Wei-Hsi Chen. I'm still a PhD student in Dan's lab. In fact, I'm the representative of Dan's PhD student. And today I'm going to talk about learning to collaborate. And, oh, wait, what is this? Oh, okay. So I probably should explain what's a collaborate. Let me pause a bit and I'll come back to this later. So it was a lunch, and Dan took me to this restaurant, Honey's, and it was pretty ironic because at that time I was feeling I'm in the phase of wandering in the deserts, and I was nowhere near the land of milk and honey, and I'm just still trying to figure out what I'm trying to do. And Dan told me that he likes to work with collaborators that teaches him something that he doesn't know and always could prove him wrong about some assumptions or some things that he believes. And so I was fortunate enough to then find something that I wanted to do later. But this philosophy of working with someone who knows something that you don't know inspired me. So here I'm going to define collaboration. And so collaboration is to collaborate with someone that can teach you something you don't know. Whether this collaboration leads to yourself or someone being wrong with their original assumption, it doesn't matter because knowledge is being produced. And so then I was participating in the SLICE project. And in this project, I was asking this question of whether it's possible to create this dynamical robots of different size through an origami design automatically. So here we're going to talk about a little bit about these three aspects. And so we have the dynamical robots out of origamis. We can automatically generate the origami structure, and what about like different size? So here is just a quick result of our dynamical robot hoppers. So here we can store the energy inside the origami springs, and it can then release to achieve the exact height that we want it to be. So it's a controllable height. So this is the dynamical part. And then we decided to make the whole robot out of origami because why not? So we have these different origami modules, and we decided to make them into a robot. And then it's like, how do you prove them? Because you made a very bold statement that you can fold any robot out of like a piece of sheet. So that was my mistake. And then I spent a lot of time dealing with this mistake. And then it turns out that origami robots are path planning problems. And suddenly Dan's like, oh, this I can help. And so we take the origami design problem and translate it into path planning problem, and suddenly we have a design. So here we have a robot that is made out of this algorithm, and it was designed and fabricated and made within 2 hours. And it can, oh, if you didn't see, it did throw the hoops. And so this is the project that I'm working on. I'm having a lot of origami modules, and then I take them into this algorithm that can generate a robot. And then eventually we wanted to put some actuation on top of them and modulate it so that eventually we have a squirrel robot in the end. And so talking about collaboration, these are all the people that are collaborating with me on like several different projects. There's still a lot of people that I couldn't find like a good photo that can put on it, but there's a lot. And And so I would encourage everybody to collaborate, and here are other people that collaborate with me that is outside of the academic life. So we have teachers that we're working on. We went on a field trip to film movies with Rex. We even have like artists working with us to create like new type of knowledge using the engineering tools that we have. So thank you very much.